All right, it's going. Okay, good. I'm gonna start by saying it's ridiculous. We have homework next week during Thanksgiving break. Now that I got that out of the way, everyone's here. Okay. Okay, so let's go through the assignment.
Pretty sure I most of it wrong.
I might have too. I spent a good amount of time on this one though. Like, this is one of those ones I feel like you really had to dig to find the answers. So I guess just going through number one, transcription in E. coli. So I pulled this straight from the instructor notes, and I just put down the minus 35 sequence, minus 10 sequence, and the plus 1 sequence. Did you guys get anything similar?
That's what I got.
Okay.
I put in also the sequence that went with it.
Yeah, I did as well. So it's like TTGACA.
Yeah, because I was like,
Yeah.
I was like, if I get this wrong,
I just missed the first one. I got the other two.
Okay, cool. B, this one, I put RNA polymerase hollow enzyme. That's probably wrong, but that's what you got.
is
Okay.
that's with the alpha, like the two alphas, and then that's a beta, right? And the beta prime and then W.
Yeah,
That's
because the polymerase is made up of multiple proteins. It's I honestly don't remember where I pulled this directly from, but C, this one I had a hard time finding. I ended up just putting RNA polymerase. There's probably more to it, really. Okay, all right, cool. Did you get something different, Tyler?
No.
Okay, cool. D, I put the rut, and that's all I got. I'm sure there's more.
I put a stem loop, which is hydrogen bonds between G and C.
Yeah.
Stem loop.
That's it. That's it, really. And it's it run as well.
And Terminator sequence,
Okay.
which says it's an adenine
Proteins.
You guys get real quick.
Yeah. I also put the NUSA protein. Yeah. Okay. Okay. And we get 2A.
I think I had to look this one up on Google. So I don't know if it's right. Is the ADPA enables specific binding of RNA polymerase to extreme products? What do you have
To stream transcribe at a function rate.
I put it recognizes the promoter and targets RNA polymerase gene.
I think we have the same thing.
It sounds similar, so I'm guessing we're on the same page. Yeah.
It binds to negative 10 through 5 sequence and guides to the promoter.
All right. I think we're all on the same track there.
Yeah.
Oh yeah, because it has the other ones. I guess so the benefit of having C.
Yeah.
But what's B?
I had each essential genes and pathways operating.
Yeah. I put the same thing.
C, I also wasn't sure about. I put different sigma factors recognize different promoter region sequences.
Another thing I put in is just like they have different specialties. Like for example, like the heat shock sigma factor. It's just like a heat shock protein that it's activated at a certain temperature and it prevents like degradation overall. And then I'm And then I just kind of made an assumption with the nitrogen starvation one. I really didn't know, so I just kind of said that, like, perhaps that in a situation where it's starved of certain materials like nitrogen, I don't know, that it functions. I don't know. I just
Well, yeah, because like the Sigma 70 could not function during that time, so that would that's
yeah,
what I
yeah. I don't know.
I didn't do just like that. I was
This one, yeah, this one I was a little confused on. I put trans acting factors and the 5 GTFs. It's like TF2D, TF2B, TF, all those. Did you get those too?
Yeah.
Okay. What would you guys put for 3-day? This one, I had a long, complicated answer.
Yeah, so I feel like
I put a really short one.
Really? Okay.
Yeah.
something that you like separately, and then you like to do
Yeah, I said row dependent has a rut and a stem loop, while row independent does not have rut, has a hairpin loop, and has another protein slow RNA polymerase, and that is SA. It's all good. And I was like, oh, that's good enough.
So they both. So which one has a hairpin loop and which one has a stem loop? Or are they the same?
Independent has a hairpin loop. You know, I don't remember.
Because both have a loop. That's what
Yeah,
I
I
got.
don't remember what a hairpin loop was.
I don't know. Because I remember.
Yeah, it doesn't like explain what a hairpin loop is.
Because I don't know. This one was probably one of the more confusing ones. I spent a lot of time on this stupid question, just trying to figure it out. Because I know both have some kind of loop.
Oh wait,
Just I don't know if they're different
Oh, no.
loops or if it's the same
it's the
kind
same.
of loop.
I think they both
It's the same.
use stem loop.
Okay. Okay. So it's the same thing.
Oh yeah, because now it's been a while since I read this.
So the
and it
difference
says-
just is like what like holds it together and then what initiates termination, basically. I think.
Oh yeah, because it says called the stem loop or hairpin loop, and it says the stem loop is formed when cytosines and guanosines are transcribed from the terminator DNA sequence.
Yeah. Okay. Cool. Well, and I guess that makes the answer to B pretty simple then. Both use a hairpin loop or a stem loop, whichever you call it.
Yeah, that's all I had on that one.
Yeah. C and D were kind of weird.
Yeah, I just took like a lot.
yeah, me too. I don't know. It's kind of shot in the dark there.
Oh wait, oh I didn't do it.
I just put remove rep side and then speed RNA polymerase
Yeah.
because I wouldn't catch up to it faster. I don't know if that's impossible.
Yeah, exactly. Like, well, and like one of the things it says, like, think in terms of specific changes you can make to the DNA. I'm like, can you make specific changes to the DNA sequence? Like,
Well yeah, you can take out the GC sequences, right?
yeah, and that would prevent it from working if you can do that. So, and that's what I put basically.
What I was thinking.
And then with D is basically the same thing. Then I said just like if you could remove the termination sequence, the adenine chain, then it wouldn't stop.
Because that affects the capability. You're right.
Yeah, 4A.
I put Tata
That's where I got to.
proteins. I just had RNA polymerase. What do you have?
I put the TT or TF2D, TF2B, TF2F. I put those.
So I put the mediator protein complex and the basal transcription apparatus. I don't know if those are right or not.
It sounds right.
Who knows? I really have no idea. I really don't.
What?
I just remember reading it. It's in the instructor notes somewhere where it talks about requirements for basal transcription, but it was also talking about regulated transcription in the same paragraph. So that's where I was confused.
And here it says RNA polymerase too.
Really? Okay.
I just said RNA polymerase.
So RNA polymerase too. Okay. Do you have anything else?
It also has the TF2s, all those TF2D, TF2B,
Okay.
TF2F.
And you know how to set up the
Okay.
So
Well,
let's start with the left story. So it's going to debit payments receivable, is receivable, and then credit equipment is 100. So it's honestly it's simply because it's like
Sorry, I'm still running it.
credit equipment, credit and then this is just I mean, and it's all right here. And then you receive the cash payment each. Yeah, basically.
Okay.
Credit.
So, and this question also had like a second part, and it is like I might have just screwed up the format of mine. But it says like what DNA sequences are involved in regulated transcription in eukaryotes.
So I had 4 promoter, regulatory DNA sequences, enhancers, silencers.
What was that last one? Enhancers?
Enhancers and silencers.
Okay.
Here's everything.
I had everything except for the last one. Yeah.
And so in this case, it's actually for the first one.
Okay. And then
And so
4C, what proteins are involved in regulated transcription in eukaryotes? That one I put TATA binding proteins and the TF2D, TF2B, TF2F, all those. Did you guys get anything similar? No? What'd you put?
I put the -25 plus 1, but I figured I was wrong.
Wait, for proteins or for sequences?
For D.
Wait,
Oh,
for C, 4C.
Wait, C.
Wait,
D is protein. Isn't it?
shoot, I might have messed up the format of mine.
I have D as what?
C is the DNA sequences,
Okay, yeah, the format screwed up on mine.
and so the DNA sequence are the promoter, the regulatory transcription factors, the enhancer, and silencers.
Yeah.
Yeah.
Protein. Yeah, RNA polymerase 2, TF, all those.
Yeah.
Activators, repressors, and mediator.
Okay.
Okay, so let's see. Okay, so that let's see.
Okay.
Operating.
Question concerns the 3 major RNA modifications discussed in this lesson.
Okay,
Suppose a pre-mRNA is produced by transcription. Oh, this one. So this one, So I ended up just putting the 5' capping, 3' polyadenylation, RNA editing, and then base modification.
Okay, what was the last one?
Base modification.
I had intron splicing, RNA splicing.
For the last one?
Yeah.
Is that what it says on there?
It says intron splicing.
Okay. So what was that again? Something splicing?
Intron.
Intron splice. Oh, okay. Yeah, that makes sense. That makes sense.
So if you just have one pyrolytic center, do the one.
Did anyone get 5B?
Well, it said what it was.
Yeah, I think I honestly just Googled it and copy and pasted.
Where did it say that? It says it in here. What's it?
I put RNA molecule capable of catalyzing reactions. Splicing it.
Okay, yeah, that's basically exactly what I got.
It says splicing occurs by self-splicing the pre-mRNA catalyzes the removal of its own intron. These catalytic pre-mRNAs are also called ribosomes.
Okay. And C and D were the only ones I didn't get to yet.
I didn't do D. I got C.
Okay.
It's in RNP. It says I put may catalyze the enzymatic cleavages responsible for removing introns.
I run through a couple of
Or it could be more.
Did you get that?
Like I said, C and D were the only ones I didn't get to yet.
No, did
So.
you write that down?
Oh yeah. Yeah.
So the guanosine nucleoside serves as a cofactor of the reaction and is a binding site within the intron.
That's how I learned.
Yeah, that's actually
Did you get that?
Yeah, I got it.
CPSF leads to the RNA 10 to 35 nucleotides downstream.
also recognizes polyadenylation.
What was that again? It recognizes.
Polyadenylation signature.
Okay.
It says, it also after that says, three mRNA and 35 nucleotides downstream.
Maybe
Okay.
I forgot to put M.
Like, once I do it on my own, I remember.
mRNA.
There's a couple things that
You need that.
like, if I watch,
No, I got it.
like, I just, I understand it better.
Polypolymerase
So like,
attaches many, about 250 adenine nucleotides to the 3' end of the transcript.
because you're right.
And then guanylyl transferase hydrolyzes BTP into GMP and pyrophosphate. There's a 5' to 5' linkage, which is hard to break down.
There's a what? 3,
5'.
5', 5'.
And that's hard to break down.
All right, and then D.
You have to draw an image.
Oh, okay. Huh.
I just, sure this is wrong. I just found this, it was like in the PowerPoint. I just copied it. But I really don't know what you're talking about.
Is that
Like,
like?
it said, it talks about introns identified by electron microscope in the question.
Yeah.
And the title of the slide says identifying introns. by
Oh,
electron
there you go.
Oh, something will look like
So
that.
I copied that bottom.
Okay.
Will it look like
Yeah.
this?
Yeah.
I'm just gonna recreate it in Paint and call it good. Sweet.
It looks something like that.
That's way more than what I'll do, but yeah. That's good.
Well, with that.
That's the picture.
Yeah, it's gonna be. I was like, kind of